Hello again. In this video, we'll have a mini exercise, which we'll get to, and we'll continue working on the portfolio model spreadsheet where we built the R matrix of historical average returns. We built the variance covariance matrix, which I signify here, right? A 3x3 matrix of variances and covariances. And then we'll use that to feed an optimization, right? And then just to recap our optimization, like what are the two things we would want to do? Given some return objective, right? An expected portfolio return, like a good level. Suppose it's 9%. That's what our mini exercise will be based on today, actually. Suppose we have a return objective of 9%. What's the best portfolio with an average return of 9%? Well, it's the one with the least risk, right? Minimize the portfolio's standard deviation. And let me find the Greek letter sigma. Here we go. Minimize portfolio standard deviation, right? Or given some risk limitation, suppose we've got some risk limitation, we'll call it sigma p star, some good level of risk that we don't want to exceed, right? Some maximum risk we can take on. Given sigma p star, what's the best portfolio with the standard deviation of something like 12%, for example, right? What's that best portfolio? It's the one that with the highest expected return, maximize expected portfolio return. So that's what we want to make sure we do. You'll be accountable for building that out on the exam, and we'll talk about that in an exam review video in the future. But for now, let's work on building the spreadsheet out. So under in-class exercises, we're going to work on this portfolio models working version spreadsheet. In the previous video, we built the R matrix of historical average returns. We built the variance covariance matrix S using the data analysis tool pack, which was great. And so from here, let's compute the portfolio's expected return and variance and standard deviation using matrix operations like we did in the past, but just a brief recap I think is in order since it's been a while. So the mmult function is how we multiply matrices, and looking at how to compute a portfolio's expected return and variance, they're right here, right? Expected return, X transpose times R. Portfolio variance, X transpose times S times X. Let's do expected return first. Before we do, we need a matrix of weights, like just for example. So here's a 3x1 area that would be a good spot for a matrix of weights, yeah? So suppose we, for illustrated purposes, invest 50% in the S&P 500, 30% in the 10-year treasuries, and 20% in 10-year corporate BBB rated bonds. The weights have to sum to 1. It's handy to have a cell right underneath the weights that sums them, because you saw we use solver that's one of the conditions, the constraints, that the weights sum to 1 always. So let's find the portfolio's expected return, X transpose times R. Remember the mmult function takes two arguments. The first argument will be X transpose, right? So transpose, parentheses, transpose of X. Here's X transpose. Close out that. And then multiply that by R. So taking X transpose, a 1x3 matrix, times R, a 3x1 matrix, will give us a 1x1 result. That's exactly what we want. And so this portfolio's expected return is 10.847%. Let's find this portfolio's variance, its risk, right? How volatile are the returns? To multiply three matrices, remember we nest two calls of the mmult function, right? Equals mmult, mmult, and then this inner mmult takes two arguments like all mmult functions do. The first one is the transpose matrix of weights, right? X transpose times S times X is the whole equation for variance of a portfolio. So mmult of X transpose, and then S is the next argument. Close that out. All right, so this whole thing, this inner mmult function says take X transpose and multiply it by S. Right? That whole thing becomes the first argument of the outer mmult function. So let's separate this by a comma. So X transpose times S And then the second argument of this outer mmult function is x again, right? X transpose times S times X. Control, Shift, Enter. There's the portfolio's variance. This is what we've done in Excel. X transpose times S times X. Nice. And then taking the square root of that, raise that to the 0.5 power. Here's the standard deviation. Okay, and that looks good. So that brings us to our mini exercise. From here, you could do the solver optimization like we did in the previous video. Given some return objective, minimize standard deviation, for example. And that's exactly what we'll do. Right? Here's the mini exercise. Suppose our return objective is 9%, 0.09 objective. So the mini exercise will say, suppose we have a return objective of 9%. What's the best portfolio? It's the one that minimizes the riskiness, right? Find the portfolio with an expected return of 9% that minimizes portfolio standard deviation. So that's what you'll submit for the mini exercise, the weights, the optimal combination of weights. So, nice work on this video. In the next one, we'll talk about some short sales, and I look forward to it. Thanks. Bye.